Hello, everyone. This is the voice that normally does the practice problems, but I wanted to check in for a minute because there's an important formula coming up that can cause some headaches because, honestly, the notation for it is kind of lousy and people find it confusing. And the formula we're talking about is the one where you find total enthalpy equals number of moles times molar enthalpy. And I'm going to write that out in a couple of different forms, but before we do that, let's talk about bananas for a minute, just to get ourselves set up. So, a person goes to the store, bananas are $2 each, they buy 7 bananas. How much did they spend? 1 second of thought later, $14 is the answer. And the way you'd figure this out is you'd take the number of bananas they bought, multiplied by the price per banana, which in this case was $2. And when you multiply those, because units cancel, we'll get bananas gone, and our answer will just be 7 times 2 is 14, and that answer will come out in dollars. I assume nobody has any trouble with that. But the chemical equation is a lot like this, so I want to get some things organized before we start out. This number over here is the total money. This here is the number of bananas. We're going to be saying number of moles in a minute. And this number here is the money per banana. Now, what makes this confusing when we're talking chemistry is that, or what could make it confusing, I guess, if you were talking about groceries, is that this number and this number are both about money, and in some sense they're both about how expensive are bananas. But you can see how they measure it in different ways. This number is true for everyone, and it doesn't matter if you're here to buy 1 banana or 0.3 of a banana or 4 million bananas. This price applies to everybody, and it's the same all the time. Then you multiply that by how many bananas you want to buy, and that could be 1 or 0.3 or a million. And then over here comes your amount of money that's specific to the amount of bananas you bought. So if that makes sense, just before I get back to a blank screen, the analogy with chemistry is that we have an equation that's going to talk about total enthalpy enthalpy and energy are very close to the same thing. There are some details that make them not exactly the same, but they're interchangeable almost all the time, and in this course I use them pretty interchangeably. So total enthalpy equals, and then we're going to have the number of moles of some species that's reacting, and we're going to multiply that by what's called the molar enthalpy, as in the enthalpy per mole. And just like with the money example, enthalpy is going to be measured in joules or kilojoules or megajoules. Kilo is the most common. Moles are measured in moles. And molar enthalpy is usually measured in kilojoules per mole. So when people see two terms with enthalpy in them and they both have kilojoules in them, they get a little messed up sometimes. The difference is this one should always be in kilojoules and this one should be kilojoules per mole, and that's how you can tell the difference. Now, sadly, people are not always careful about this, and sometimes when someone is talking fast, they will just call this the enthalpy, or they'll just say the kilojoules and not say the per mole part, and that is what makes life difficult. But we'll deal with that one question at a time. Let me go back to the actual formula that I've been hyping for several minutes now, and I'll show you how it can look. In our notes, Les writes the formula like this: delta subscript R H, which means the change in enthalpy from the reaction, equals the number of moles times delta R H M. And this M is the part that means molar. And this reminds you that your energy should be, or this number should be given in kilojoules per mole of something. It shouldn't just be kilojoules. This one that does not have the M is a total enthalpy, and that should be measured in just energy units. I don't like this notation because delta RH and delta RHM are way too close together, but it does get used a lot, and honestly, this is not the worst thing you're going to see out there. In the textbook, they write this a little bit differently. They just put delta H on the left side equals N, and then on the right they put delta RH. You can see how this could be confusing if you're going from the notes to the textbook, because they both use delta RH, but tragically they use it for different things. In the book, this one is your molar enthalpy, and there's nothing in their notation that would indicate that. I generally think Inquiry into Chemistry is a decent book, but I am really unhappy with how they do this. And so, when I'm writing these, my version looks like this. I use a big loopy E to mean enthalpy or energy, and this is the one that's measured in kilojoules, and the delta H is the molar one. That's the one that would be measured in kilojoules per mole. And it should be kilojoules per mole of some substance. As you'll see in the examples, I'll nag you about saying, if you write moles, say moles of what. So, main message, I'm sorry about this. On behalf of chemistry, I apologize for this crummy notation, but all of these mean the same thing. I suggest you pick one version of this and just try to use it consistently, and if someone shows you another version, smile politely and don't listen. Get one version that works for yourself and just stay with it. And hopefully that'll be enough to get you through it. We'll see you in the practice problems, and we'll nail this down with some examples and lots of work. See you there.